Okay. Cool. So let's get started. First of all, I want to thank all the diehard fans who decided to hang out with me on a Friday afternoon. I know it's not easy, but I know you're big fans, so thank you for coming. My name is Vijay. I'm a program manager in the Hyper-V team, and with me is Mike. He's going to be doing the customer presentation. And let's get started. So before I begin, I just want to start having a little bit of fun. So first I'll do a little bit of survey and talk about, what are the results of that survey. About a year ago, Symantec actually did a survey and tried to find out how many customers are having a disaster recovery plan. And the first question they asked was, how many outages do you have every year? Any guesses in the audience? Okay. I think I heard someone say C. Okay. That's the correct answer. Next question was, what's the downtime cost associated with each of these failures? Any guesses there? Okay. Someone said D, but it's actually 6 times D. I just don't even have that solution in the question. So if you think about that, the next question is going to be, how many people actually have a DR plan today, and how many do not? And any guesses there? Okay, I think someone said D. But that's really surprising, because if you think about the cost associated with a DR, if you're having an outage, many customers going out of business, you would think that DR must be a priority for many customers. But the answer is no. And there are many reasons why DR is not a priority for many customers. The first reason is that when you think about DR, many SMB customers do not have the infrastructure needed to deploy their DR plan. And when you talk about DR, it's often associated with SAN devices that you need to buy, and you have to enable replication on the SAN devices. And on top of that, you have the management software for which you need to pay licenses, and you have to manage the whole thing. It's pretty darn complex. And the third reason where customers don't have a DR plan is because they don't have the right people and processes in place. So folks, I can assure you that I can do not give you the help that you need in terms of the people and processes. But I can tell you how you can get an affordable solution that can enable your DR. So when we started doing the planning exercise in Windows Server 2012, we actually did a survey and found out that DR is the #2 reason why people virtualize their workloads. And that's precisely why, folks, we actually built Hyper-V Replica. So, and the other thing I just want to call out is, I do not want anyone here in the audience or those people there to be one of these guys who have a DR plan that looks like this. So it's not a question of if you should consider Hyper-V Replica for your DR plan, but when you consider Hyper-V Replica for your DR plan, I want you to be confident about the solution, and I'm here to help you, give you all the resources that you need to have a successful deployment. So the jokes aside, I just want to get to some serious stuff, talking about what is the session objectives. The first important thing I want to highlight is what's Hyper-V Replica, how to enable it, what are the capabilities, and what is the value proposition. And at the end, we'll actually talk about some of the deployment considerations as part of Hyper-V Replica. And at the end, Mike is actually going to do something more amazing. So with Windows Server 2008 R2, you can actually enable your VMs to be highly available. The moment you make them highly available, if you have outage of your host machine, you can simply failover your virtual machine to another node in the cluster. But suppose you have outage of your primary infrastructure, that's when Hyper-V Replica comes into the picture. With Hyper-V Replica, we'll continuously protect your virtual machines from an outage of your primary infrastructure. So what's in the heart of Hyper-V Replica? It's essentially an inbox replication product which does asynchronous replication, and it does that from one Hyper-V host to another Hyper-V host. And it does that at the granularity of a VM. Once you've enabled replication, you have a VM that's sitting on the replica side, and it is in a passive standby state that you can turn it on in the case of a disaster, or if you have some kind of outage of your primary data center. And you could also use that VM for testing purposes, which we'll go through as we do the demos and stuff. An important attribute that I want to call out in the case of Hyper-V Replica is the fact that it's an application agnostic feature. What I mean by that is once you virtualize your applications, put them in a VM, you can turn on replication without the application being aware of that. So that way, it actually works for all kinds of applications, also for legacy applications for which you may not have a DR plan. The other important aspect that I want to call out with respect to Hyper-V Replica is the storage agnostic behavior. What I mean by that? So if I have invested in SAN device on my primary, I do not have to have the same kind of storage on my replica side. I could actually replicate from SAN to an SMB store. I can replicate from SAN to a direct attached storage, or I can actually mix and match. So I can go from SAN to DAS, DAS to SMB, all kind of combinations. So net-net, it's affordable because you don't need to buy expensive hardware. You can actually go with commodity hardware and enable the solution. The second important thing is it's easy to manage. As you can see from the demos, I'll actually go and illustrate that. And you can manage this from Hyper-V Manager. You can manage this from Failover Cluster Manager. And you also have the power of PowerShell to script all these steps. And we're also working with SCVMM in the SP1 timeframe to make sure that all these functionalities are also available in that timeframe. And last but not least, it's a flexible deployment solution because, like I said, you can use different storage types on your primary and replica, but also you can replicate between a clustered environment and a non-clustered environment, or from a standalone to standalone, or you can mix and match these combinations too. So talking about flexible deployment, let me start with the first deployment type. The first deployment type is I'm an SMB customer, and I need to enable protection for my workloads on my head office. So if I need to do that, I can simply enable replication. I can use my branch office as my DR site and start replicating my VMs. Notice in the picture, I actually show you a SAN on the primary with a cluster, and on the replica side, I have a direct attached storage, so I can do this replication. But not only that, if I have workloads already on my branch office, I can replicate them back to my head office. So you can actually have some kind of bidirectional replication going on. So for VMs, head office to branch office, another set of VMs from branch office to head office. So this is not just for SMB customers, but also if you have enterprise customers, or you're a service provider like a hoster, and you have VMs that are part of your data center, you can offer DR as a protection for these VMs. The next type of deployment is replication between SMB and hoster. So if I'm an SMB customer, as I mentioned to you, I may not have an infrastructure to do my DR. In which case, with Hyper-V Replica, we're actually opening up the possibility that the SMB customer can now subscribe to a subscription in the hoster's data center and enable replication to that hoster. And to the hoster, all you're paying for is the storage, because notice that on the replica side, you're not turning on the VMs. So in the event of a disaster, then if my office is underwater, then all I can do is fail over my VMs to the hosted data center, and at that time is when I actually go ahead and pay for the compute resources on the hoster's data center. So this is very, very powerful because it's beneficial both for the SMB customer as well as for the hosters. It's really a win-win situation. So let me go ahead and start talking about the replication capabilities. Instead of talking about that, I'll actually go through the UI to kind of show you how this is all set up. So before I go ahead and do this setup, the first thing I want to actually call out is you need to make sure that you enable broker on your clustered environment. So here I have a setup where I have a 2-node cluster with FS3 and FS4. And on the right-hand side, I have the Replica, which is a standalone Hyper-V host. And on the primary side, I have enabled broker because I need it. I'll talk about why you need a broker a little later in the presentation. Okay? Once I've enabled the broker, I could simply go to the Replica server, and I need to make sure that I enable replication on the Replica server. Once I enable replication, I have a few choices here. So I can either use HTTP for my connection, or I can use HTTPS for my connection. I use HTTP when I'm trying to replicate between two organizations that have trust between them. So in this case, we're going to use Kerberos delegation and use the machine accounts to do the mutual authentication. But if I'm replicating across two organizations that do not have trust, you can enable that using HTTPS. And in that case, what we're doing is using certificates to actually do the authentication. So we authenticate the primary with the replica, and similarly, we authenticate the replica with the primary. Once I've done that, the next thing I need to do is specify the authorization. So this is very important from security point of view, that you only authorize the primary servers that you want to enable replication. So on the replica, you say who's allowed to replicate to me. Okay? Once you've done that, the last step is to actually specify the storage location. Okay? So that's the storage location. Remember, the storage location is the default storage location where you will place your VHTs initially. But once you've put them in the initial location, if you need to storage migrate them later in the cycle of the VM, you can always go ahead and do that. And if your replica happens to be a cluster machine, make sure that the storage location is a clustered location, which is it must be a CSV. If it is a you're using SAN, or or if you're using SAN with CSV, you should make sure it's in that location. If it's an SMB cluster, you can actually put that in an SMB share. Once I'm done with that, now I'm actually ready to go to the primary, and for each VM that I want to enable replication, I can go ahead and do that. So here I have a VM that's running, and I can simply go ahead and enable replication. So let me just. So I need to type in the fully qualified domain name of the replica server here. While this is going on, I just want to take a quick poll of folks who've already attended the TechEd hands-on labs. Have you guys looked at the hands-on labs? Okay. Any? Okay. Not many, so I'll probably go through all the screens one by one. So once I have specified the replica server name, what I need to do is specify what type of authentication I want to use. So on the server side, you notice I say I can allow both Kerberos and HTTPS. But on the client side, which is my primary server, I get to specify the specific one I want to use. So in this case, I'm going to use Kerberos. And the next step is I specify what VHTs I want to replicate. So by default, all VHTs should be replicated. But you have the flexibility to actually skip VHTs that are not critical to the functioning of the VM. For instance, if I have ISO images, or if I have page files that I put in a separate VHT, I can simply go ahead and skip that VHT from replication, because it's just going to generate unnecessary traffic for you. Okay. Now, once I'm done with that, this is a very important page, because it's going to take a while for me to explain this. Okay. So once you've enabled replication, what we do is we create a crash-consistent copy of the VM on the replica side, right? And that's what you get by default. But if you want, and you want to fail over to an older point in time because you had a virus attack, you want to just fail over, go to an older point in time, you can always go ahead and specify the recovery point. Okay? So once you do that, you get the option to specify how many recovery points you want to store. Okay? You can store up to 15. But remember that these snapshots or the recovery points are 1 hour apart, and these recovery points can either be crash consistent or app consistent snapshots. So the moment I turn on VSS, I also get app consistent snapshots. This is very important to remember because if I don't do that, I'm not going to get app consistent snapshots. So when I turn on app consistent, you also specify how frequently you want to take the app consistent snapshots. Okay? So you can do it every hour, or you could do every 4 hours or every 12 hours. So you can actually space your app consistent snapshots. The reason we have a configuration for this is because when you're doing app consistent snapshot, what we're really doing is going to the primary VM, triggering a VSS snapshot, we're coalescing all the workloads in the VM, and then taking a snapshot of that, putting that as part of the log file, and then replicating it over the replica server. So the impact on the primary VM when you're doing app consistent could be dependent on your workload. So that's why we have it as an option. So once I'm done with that, the next thing I get to choose is what's the method of initial replication. So by default, the UI gives a default of doing initial replication over the wire. But obviously, if you have a VHD that's very large or your network bandwidth is very, very small, you want to consider using offline ways of sending your initial copy of VHDs. So we give you 2 options to do that. The first option is you can use an external media, and you can basically do a import to the external media, take that external media over to Replica, and then import it over there. Or there's a third option, which is basically enables you to use a existing backup copy. So if, let's say, you're doing an offsite backup to your DR site, can I leverage that offsite backup copy for my DR? So the answer is yes. So the moment you restore that offsite backup copy, you can seed your replication from that point onwards. In addition to that, we also give you the option of choosing what's the schedule for your initial replication. Note this is just for initial replication. So the reason we have that for initial replication is because it can be a very expensive operation if you're doing online IR, right? So we want to make sure that you stagger the initial replication, or if you want to postpone it to off-peak hours, you can do that. So I'm just going to pick finish. And once I'm done with that, I will have a VM created on the replica side. There you go. And I can actually check the status of replication. You can see on the right-hand bottom corner that the primary server is my cluster, and my replica server is my standalone machine, and it tells me when was the last time it synchronized. So if I want to do more monitoring, if I want to just go more, look at all the details of replication, I actually can do that very easily. So here I have a VM that I want to monitor the replication. So I can go to the view replication health, and it tells me more details about the replication health. It tells me if it is in a normal condition, warning, or a critical condition. So the warning and critical all depends on how healthy your replication's been. For instance, if your latency is going up significantly, then we'll go from normal to warning to critical. So that's what the replication health means. It also tells you information about what's the replication size, what's the average latency. And you also have something very interesting, because in the UI, you can actually click on View Events, and what that'll do is it'll open the event viewer, and it'll pretty much filter down what are the events specific to that VM that have caused this failure. So you actually have a very nice graphical way to kind of transition from your Hyper-V manager and go to your event viewer. And by the way, all these things that I'm showing you here, you can do that, like I said, from Hyper-V manager. You can also do this from failover cluster manager if your VM is a highly available VM. Okay? So now I showed you all of these things from UI, but what about PowerShell? Okay? So with Hyper-V Replica, we have about 24 commandlets as part of the Windows Server 2012. And here are some of the commands that are part of Hyper-V Replica. So you can do get help. You'll get the commands with respect to failover. You can also do get help replication. And these are all the commands that are pertaining to replication. So you can actually set replication settings. You can change them. You can view the settings. And you can also do things like measure VM replication if I want to know what's the status of any particular VM. So there you go. You can actually see that there are a bunch of VMs. There's at least one VM that's in critical state. I'll find out why it's critical. I'll show you how that I can do that. And I can also see that what's the replication size and what's the latency associated with the VMs. So here I have a file share VM that is in a critical state, and I want to find out, whenever these events happen, I want to find out why this is happening, or I want to be alerted before it happens. So one of the guys in my test team actually wrote a nice script which basically runs through these VM states and dumps a file over here, and it tells me why the replication has failed. For instance, if I have VMs here that have been suspended for a period of time, it tells me that the replication is paused, so I can easily find out why I'm in critical state. I have intentionally paused my replication. It tells me that. It also tells me that the replication has been behind for more than an hour, so it's time that you need to take action. Okay? With that, I'm done with the replication demo. So let me switch back to the slides. Okay. So we talked about how to enable replication. We also talked about how to do initial replication. So let me take a quick peek at what's happening behind the scenes. So here I'm talking about two hosts, which are primary and replica host, and I've enabled replication between the two. The first thing that happens is when I start replication, the primary host acts as a HTTP client and makes a request to the HTTP server on the other side, which is the replica host. So it's very critical to remember that it works on HTTP or TCP IP. So it can pretty much work on a WAN environment, can also work in a LAN environment. And all you need to make sure is if you have firewalls in the middle, you need to make sure those ports necessary are open. Okay? So once you've done that, the replication process begins. It checks whether the VM exists on the other side. If it does not exist, it creates one, or that's by default. Once that's done, it sends the initial copy of the VHTs. Once the VHTs are all settled down, then the Delta replication process really begins. And in Delta replication, what we really do is we create a log file that tracks changes for the VM. And this is actually sitting in the kernel mode of the VHT driver. And there we start tracking changes as they happen to the VM. There is one log file associated with each VHT that's associated with the VM. And every 5 minutes, what we do is ship that log across the wire using the HTTP connection and apply that on the VHT, on the replica side. And this process continues every 5 minutes because, once you've set it up, it's all set and forget. All of this happens behind the scenes. Okay? So we talked about how replication works, in a continuous fashion. But the next question is, what happens if there are failures associated with replication, right? So for instance, if you have network outage, how does replication deal with network outage? The answer is it's quite simple because we've designed it such a way that it's set and forget. So once you've set up replication will continuously keep checking whether the network is available. Once the network is available, it will go ahead and retry and resume replication from wherever it left off. So for instance, if I need to send 100 megabytes of data from the wire, and if it has already sent 80 megabytes, it's only going to send the remaining 20 megabytes to the other side. And if you had network outage that is for an extended period of time, let's say 4 hours, 6 hours, whatever the reason may be, we actually stop tracking changes on the primary because we can't let the log grow very, very large, right? So once we do that, you may ask the question, hey, now should I just nuke replication? I need to reestablish everything? The answer is no. We actually have built-in capability to do resynchronization if that situation to ever happen. Okay? So with resynchronization, what we do is do a checksum comparison of the VHT on the primary and the replica, and we only send the data changes that are missing on the other side. So that way, it's very, very gentle on your network when you're doing resynchronization. So this is about failures. So next question you're going to ask me is, hey, what about things that happen in the normal life cycle of a VM? For instance, VM mobility. So what happens if when I move the VM on the primary or on the replica, or I move the storage, what happens to replication? Do I need to tear everything down? Obvious answer is no. So again, we made sure that when you have VM mobility situations, for instance, you're moving your VM, we take care of that seamlessly, right? And we'll look into how that is done in just a second, okay? The important thing is it actually works whether you're doing live migration, quick migration, and storage migration as well. So as part of storage migration, the log file that's tracking changes, that also gets moved with the storage, right? And this works not just when you're doing within a cluster, but also if you're doing migration across cluster or across standalone machines. The demo that Ben did yesterday, I don't know how many of you guys attended that yesterday? Raise your hands. Okay. Few of you. So in that demo, he kind of shows how to do storage migration and live migration. And as part of that, if you have that VM enabled for replication, that will also move with that. Okay. So let's look at how this is done. It's actually pretty simple. Once you see what is happening behind the scenes. So you can see that there are two VMs. There's a VM that's replicating, and you have two Hyper-V hosts. The moment that the VM migrates to another host, what the Hyper-V host on the source checks is that the VM is no longer there, and it stops replicating. Okay? And the moment the VM registers on the new Hyper-V host, the Hyper-V host detects that this VM has been part of an existing relationship with the replica server. And once it detects that, it automatically initiates a HTTP request to the replica server and establishes the replication. So it's that simple. So the important thing that you need to remember is, once you've done this migration, you need to make sure that your primary server that's replicating, the target of your migration, is also authorized. So I showed you how to do authorization of primary servers on the replica. That's what you need to remember to do, because once you've set it up as once you've done the migration, the primary server needs to be able to connect to replica. But we also made this very easy for you because we allow you to specify, an entire cluster as an entity in your authorization list. So that way you don't have to specify each and every server in your primary server list. So if you have an entire cluster, you can just specify the cluster name, and pretty much we'll take care of, the cluster broker name will pretty much take care of that for you. When you're talking about replica side migration, it's actually a little bit different. So I'll just highlight what those differences are. So in case of replica side, if the VM migrates, the primary VM, when it makes a connection to the replica, it cannot find the VM. So the VM has already moved, right? So now what are you going to do about that? So the question is, how does the primary locate the VM on the replica side? And that's precisely where the Hyper-V replica broker comes into picture. So if you have a cluster and you've installed a broker, the broker tells the primary where the VM is now located, and it's actually using the cluster APIs to figure out where the VM is. And as part of that, it tells you where the VM is, and the primary now starts initiating connection to the destination replica server, right? And by the way, all of this is seamless. I'm just telling you what happens behind the scenes. And once you've set up your brokers, set up your authorization, it all works seamlessly. So now that we've talked about replication, it's a lot of talking here. Let's switch gears into DR. When you think about DR, there are actually 4 different things I want to call out. There are 4 different categories of scenarios. One scenario is testing your DR plan. Once you have set up replication, you want to make sure that when you have a disaster, you're testing for it, right? And sometimes you also have compliance needs where you need to test your DR plan once a year or once every 6 months. In fact, in MSIT, for our SAP databases, we actually make sure we do a DR once every six months, and we make sure that we can run that for a week or so. So that's the scenario number one. The second scenario is if you're doing some kind of site maintenance, you want to bring down your entire infrastructure. I mean, you already have set up your application, so you could use the same DR scenarios to do your site maintenance. The third scenario I want to call out is impending disaster. What I mean by that? So if I'm talking about disaster, let's say I have a power outage, or I am actually in the middle of a hurricane, and I'm getting the warning saying that I'm going to be hit by a hurricane, or I'm going to have power outage. So as an administrator, you can actually take the action or decision to say, okay, before this is going to hit me, I'm actually going to go ahead and do a failover, right? So that way, what you have done effectively is made sure that you have no data loss associated with your failover. So that's the scenario number 3. The scenario number 4 is sudden disaster. That's something you didn't expect. You already planned for it, but if it hits you, you can only react to it after the fact. Okay? So now let's look at how Hyper-V Replica helps you to do the DR. Okay? So the first scenario I want to introduce you to is planned failover. With planned failover, you can do testing, you can do site maintenance, and impending disaster. The key thing to remember in planned failover is there is no data loss associated with planned failure because it's planned. Okay? But there is definitely downtime associated with planned failover. Okay? And the way we do that is you have 2 Hyper-V hosts, ongoing replication. First thing is you shut down your VM on the primary, and we'll send the last bit of log. We quiesce the systems, primary and replica. Once that is done, you can pretty much fail over your VMs on the replica side. Okay? And you can start doing your testing or your site maintenance, or whatever the case may be. And while you're doing that, what we also do is we start tracking changes for your VM on the replica side. So suppose you want to, once you've done your testing, you've done a weekend of testing, and you want to come back to your primary where your workloads should run in your best performance, I can simply do reverse replication. When I do reverse replication, because we have quiesced the entire system, there is actually no data loss, and the reverse replication is very, very efficient. Okay, once you've done your DR setup, the first and foremost question that everyone asks here is, what happens to my network configuration? Because I have 2 sites, I'm going to have different subnets, I'm going to have different connectivity. How are you going to help me, right? I'm the customer, right? Okay, so I'm going to say something very obvious. I mean, everyone knows this, but I'm going to say it anyways. The first thing you need to do is, once you have set up your replica VM, on the replica side, you need to make sure the VM is connected to whatever network you want, right? And the replica VM is just another VM, so you can actually go to the VM properties, go to the network adapter, and set it. So by default, the UI will help you to match the networks and connect them for you. But if you want to connect to a different network, you can always do that. Okay? That's number 1. The number 2 is there are a lot of scenarios where people want to use VLAN tags, right? So I want to use a specific network topology for my VMs. I can also specify that. Just because it's another VM, you can go to the VM properties and specify the VLAN tags. The second, not so obvious thing is, how do I deal with the network identity? So what happens if I need to fail over to a different subnet? So here we have multiple choices here. So first is, if I have a VM that is part of a DHCP domain, let's say I'm a VDI workload, right? I'm just dealing with a lot of VMs, all are part of a DHCP, they get automatic assignment of IP addresses. So that's maybe easy because you can get that automatically, right? The important thing is you need to have a DHCP server on your replica side. The second important way is, you can, if you're a server workload, let's say, right, and you're not dealing with DHCP addresses, you can use the static IP addresses. And Hyper-V helps you to actually specify what IP address you want to provide for your replica VM. Okay? And third, which is another interesting feature that's coming up in Windows Server 2012, is the notion of network virtualization. With network virtualization, what happens is, if I'm a service provider or a hoster, right, and I have VMs sitting in my data center, and I'm providing this DR as a service, I'm enabling VMs to replicate to the other side. But for the customers, they may say, hey, I don't want to change the IP addresses. I want to use the same IP address, whether it's on the primary, on my replica, right? So in that case, with the network virtualization, what we've done in Windows Server 2012 is for your customer IP addresses, you can still preserve the same IP address on the primary and replica, and all the magic associated with mapping your client's IP address and the physical address is all taken care of using the network Hyper-V network extensible switch and the network virtualization infrastructure. And with SE 2012, we're actually making some of these experiences much better with the network virtualization. And the last, but not the least step, is if I have to use a different IP, because I'm using a static IP address, then what I need to do is update my DNS records. So that's an important step. Again, this will happen automatically if your VM is already enabled for that, but it may take time. So that's something that you want to keep in mind. Okay, now let me switch to a planned failover demo. 6, please. Okay, so here I have a bunch of VMs. So I'm going to use the file share VM to actually demonstrate the planned failover workflow. It's already running. So let me connect to the file share to see what files are over there. So I'm going to go ahead and add an image. I'm going to call it TechEd last day bitmap image. And I'm going to start my planned failover. As I said, the first step is to actually do the shutdown of the VM. Once I'm done with the shutdown, I can go right-click on the primary VM here, and I do a plan. So anytime you're doing plan failover, you're initiating that from the primary. You can go do a plan failover. And while the plan failover is going on, let's see what happens to the network connection on the other side. Okay, so I do an F5, and you can see that I have an outage because I'm doing a shutdown and I'm trying to restart the VMs on the other side. I have an outage associated with that. And you can see that the steps for planned failover. Okay, so first thing it did was shut down the VM. I mean, we had to shut down the VM. It checked to make sure that is the case. The next thing it did was check to make sure that you can do reverse replication. And it sent the last bit of delta, did a failover, did a reverse replication, and started the VM on the replica side. So these are actually individual discrete steps that you can do this with PowerShell, right? But what the UI in Hyper-V Manager is doing for you is combining all these steps and actually presenting a combined workflow that makes it very easy for customers to do this. Okay. Okay. So now you see I'm already connected to the new server here. And I have my TechEd bitmap file. How cool is that? Okay. So let me switch to PowerShell here. So again, I have two VMs as part of my demo. I have demo 1 and demo 2 VMs. And what I want to show is that I can actually script all of these steps that I just showed you and do a failover, right? I want to make sure that the VMs come up in the right order, and I can, take actions as they go. So I am going to start the PowerShell here. I already have a script written up. So it's asking me whether you want to shut down the VM. It does the plan failover. Okay. There seems to be, let me just close this thing. There seems to be a problem here. Okay. It already did the shutdown. So it does initiate the plan failover. It had done that in the last step. And then it does a failover on the replica side. And now I can go to the replica side. And I can see that these VMs are now running on the replica server. Okay? But if I find out from my application admin that, hey, my VMs are started on the replica side, but when we're starting to do testing and I can't, there's something wrong. I need to kind of revert back. I don't want to continue on this server. I want to fail back, right? So instead of committing to this failover, what I can do is simply turn off the VM, and I can simply go ahead and cancel failover. So this is like unwind, right? Or rewind, sorry. So basically, I've tried to do the failover. I went to the other side. I did my testing, and somebody in the admin team reported that these VMs are not working for me because this application has failed on failover, right? So I can simply do a cancel failover. I need to do that on the primary side as well because I did a planned failover. And I can start up the VM. So pretty much, over a weekend, if I did a trial, right, did a planned failover, didn't work, I can rewind, make sure I fix the issues, go back, try that, come back. So you can just keep doing this all day long. Okay, so let me switch back to the So I talked about planned failover here. So I shared that you can do testing with planned failover. But I also said that there is associated downtime, right? So how can you help me do testing without having downtime? So that's something interesting for customers because if I need to do this as a scheduled job, I could do that. But if I want to test this more frequently, can you enable that? So that's precisely what test failover does for you. It's a non-disruptive way of testing your workloads. So by that I mean I don't have to shut down my VMs on primary, and I do not need to pause my replication going on. And you can simply bring up the VMs on the replica side and do your testing. And important thing to note is when I do this testing, I can test any recovery point. I mentioned earlier in the demo that you can specify different recovery points. I can pick any recovery points to do my testing with test failover. And last but not least, okay, there's some problem with this. The last but not least is when I'm doing this testing, I need to make sure that the VM does not interfere with my production workload. So I want to make sure that the test VM is coming up on a separate network that is not interfering with my production network. And the way we do that is we actually take a snapshot of the VM on the replica side, create a new VM on the replica side, and we put them in an isolated network. That way, your production workloads are still running. Your application is not paused. We are still sending replication bits. We have a new VM created, and it's put in an isolated network. So let's just jump to a demo. So this demo is actually pretty complicated. We have a number of moving parts in this demo. So the demo, I have an AD VM, I have an Exchange VM, and an Outlook client. And I've enabled replication for these three VMs to a replica server. When I do test failover, what I have is 3 new VMs get created. So I have a test AD, I have a test Exchange, and a test Outlook. And they are all put in a separate test network. Okay, so let's now jump to the demo. So as I mentioned, I have the AD VM here. I have the Exchange VM, and my PC is pretty much my Outlook client. And on the London server, which is my replica server, I've already started test failover for my AD and Exchange in order to save some time for the demo. So I have the AD test VM and the Exchange test VM that are already running. For my PC test VM, for my PC, I'll go ahead and initiate test failover. So there you go. So you got a new VM created. And I'm going to go ahead and start that VM. And while that VM is going on, while the VM is getting started, let me go switch back to my primary. And on the primary, what I'm doing is I'm actually trying to ping my Exchange server. So I'm still connected. My Outlook client is still connected to my Exchange server on primary. And I'm also able to send mails. So what I'm going to do is I'm going to send mails to my colleagues, Jim and Sanjay. And actually, I'm acting as Sanjay in this case. I'm saying that I'm going to be busy with testing. Okay? So I'm sending that mail. And while that is all happening, I can actually go to my Replica site, and I can connect to the VM on the Replica site, to my test VM. And while that VM is coming up, I'll actually show you how to configure the IP addresses and the isolated network. So I go to the Replica VM here, go to the settings page. I can click on the network adapter, and you can see that I'm specifying the production network for my network. But for my test cases, I can actually specify a different virtual switch. Right? I can use a different virtual switch here. So for my testing, I'm using the test network, and for my production, I'm using a production network. And if I want to specify the IP address for my failover, you notice that I'm using a different IP address. So on the primary side, I'm using 44.0.0.2 for my exchange, and on the replica, I'm using 60.0.0.2. Okay. So let's see if our VM has come up. Okay, so the VM has come up. It's a test VM here. I can connect to it. I can open Exchange, or sorry, Outlook. I can do a ping. And when I do a ping, you'll notice that I'm actually connected. You can see that I'm connected to a different network here, and I'm using the 60.0.0.2. So this way I've demonstrated that you can actually do your testing independent of your production. Okay. So now let's jump and see if I can send some mails to myself. I'm pretending as Sanjay here. I am busy. I am on test network. Okay. There you go. So I'm sending mails to myself here, just pretending as Sanjay Shah. Okay, so that's pretty much the end of this demo here. Just going to close this window and then switch back to. Okay, so as you can see in the demos that we've actually worked very hard with a number of the teams within Microsoft, like the application teams like Exchange, SQL Server, File Server, and all these teams to make sure that what we put out as a product in Windows Server is actually we're going to work for real customers with real workloads. So this was one of our big focus efforts for us, right? Although this is an application agnostic platform, we wanted to make sure when we actually deliver this feature, it actually works in a real environment. Okay, that said, the next question is going to be, okay, I've made these demos look very easy, but what about the network capacity, right? So that's a very important question, because I don't want you to walk away thinking that once I have this, I've seen these demos, I can go home and start deploying Replica, because it's very critical that you plan your deployment and figure out what capacity you need for your replication. And the most important question around network capacity is network capacity, right? So how much bandwidth do I need? The answer is actually pretty straightforward, I mean, if you know what you're doing, right? So the first thing that you need to do is figure out for all the VMs that you're trying to replicate, what is the data churn associated with them. So you observe these VMs over a period of time, figure out what's the data churn associated with that. And if you just divide that by time, that's how much replication traffic we'll generate. So the log file that I was talking about earlier is actually linear to the workload churn that's coming out from your VMs. But just don't use that metric as it is, because there are some workloads that I can tell you that just wake up middle of the night and do something funky, right? As an administrator, you might be surprised to find those workloads, but make sure that when you're estimating these data churns, you're actually checking with workloads over a period of time, right? And make sure you're talking about peak usage. The other important thing I want to call out is the effective network bandwidth. what I mean by effective network is because if you have, let's say 1.5 Mbps, the effective network may not be 1.5 Mbps because it may be downgraded because of packet loss or latency. So you need to make sure that you send a file across the wire, see how much network bandwidth you're getting, and use that as your benchmark to say how much network bandwidth you're getting. So here I have a graph which we've done from our testing, which shows you that, that when you start increasing the amount of data churn associated with your VMs, the average latency of your application keeps going up. And this is important that if you keep increasing your network bandwidth, if you give more bandwidth to your workloads, you can pretty much reduce your network latency or replication latency. Next thing is, once you have started measuring your replication, and by the way, I forgot to mention that for the capacity planning, we're actually working on a tool, which I don't have a demo today. I can't show it to you today, but that's something that I'm working on. And that should really help you in terms of estimating how much workload churn your workloads are producing. And you can use that information to capture how much network bandwidth I need, how much storage IOPS you need, and all these things. So I'll send pointers to you guys at the end of the presentation, which will tell you, how to download the tool. It's not available right now, but we're working on it. And that'll really help you with that. OK, so coming back to the presentation. So once you have your network bandwidth figured out, the next question is, if I'm sharing the same network with other workloads or other management traffic, how do I do throttling, right? The answer is actually simple. If you use Windows Server QoS, you can pretty much set your throttling on the destination port. So you can specify for the network replication traffic, you want to use a specific bandwidth, right? You can assign weights to that. This is a new feature in Windows 2012. You can use that to set your throttling. The other important question is, hey, I've talked about replicating one VM or two VMs. Now, if I have a bunch of VMs to replicate, now how is the network utilization going to be? Okay? So the important thing is, if I'm sending replication for a large number of VMs, there may be contention issues in the network. But if I'm not sending enough VMs over the wire, I may not be using the network very efficiently or effectively. Okay? So what are the tools available for me to actually manage this, right? So in case of initial replication, as I pointed out, it's actually a very expensive operation. If you're sending lots of VHTs over the wire that you may hurt the network, you can actually use the scheduling feature to stagger these replications. But when it comes to Delta replication, what we have is a registry knob that we have set, which is based on the fact that we've taken 1.5 Mbps as our baseline and used that number to figure out what's the maximum number of parallel transfers you want to do. This doesn't mean that you can replicate only 3 VMs. It only means that at any instant or any point instant in time, there will be only 3 VMs that are replicating. So all the VMs will get their turn, and actually you can do replication. So the other important consideration when you're talking about a deployment of Hyper-V Replica is backup. So I want to make sure that is one thing that is very clear to you folks, that replication is not a replacement for backup, right? So the question is really, how do I use backup and replication together? What are the scenarios around that? The first thing I already talked about in my initial demo, that you can use the backup copy that's an offsite and use that for your initial seeding of your VMs. The second thing is, if I'm already doing backup of VMs today, that should pretty much work seamlessly. So you can do your VM backup on primary, and that will work seamlessly. The important thing to note is, if I ever do a restore, like an in-place restore of my VMs, the VMs will go into resynchronization situation. So because you kind of moved back in time, now the replication engine is kind of confused. And what should I do? So basically, it puts it in a resynchronized situation. And again, you use the resynchronization feature, which will effectively compute how much, really the data that has changed between primary and replica, and only send the delta blocks. So it's again very gentle on the network, but it does take a bit of compute resources as part of resynchronization. The other question that a lot of folks ask me is, hey, can I entirely move my backup to my replica? That's a very interesting scenario. The answer is you can do backup on replica, but I would not recommend moving your entire backup to your replica VM. There are a few reasons why that is the case. The first case is if I'm trying to doing backup on replica side, the VM, remember the VM is turned off state? So if I need to take app consistent snapshots, you cannot take app consistent snapshots. It's a turned off VM. So that's number one thing that you need to remember. The second thing is when I'm doing backups on the replica side, you're modifying the VHT while the backup is happening. So the backup pretty much puts the replication on hold until the backup is complete. So what this does to you is if you're doing backups once a week or once less often, that's okay. But if you're doing backups continuously on the replica VM, you may be putting the replication on hold for a very long period of time. And that might impact your replication latency. So this is something you want to remember as part of your backup interoperability. Next question is, hey, now I've set up replication. What's the impact on the server? Okay, the server impact is actually, we've made sure that the impact is actually very minimal. So on the primary side, we're using logs to track changes, and these log files grow linearly with your data churn. So if you ask me how much space do I need for my log files, that should tell you the answer. The second thing is the IOPS requirement on storage. Right? So again, since we're using log-based replication, the IOPS impact is 1.5 times the write IOPS. So let's say I have 20 write IOPS for my workload. We will need additional 10 IOPS for replication on the primary side. Going to the replica side, again, we've tried to minimize the impact on the replica side. The cost that you're going to pay is on storage. And as far as storage is concerned, you're replicating the entire VHT and you're making change to the VHT. So that should stay pretty much the same. The only thing is when you're turning on the recovery points, the feature that I had mentioned to you where you want to keep additional recovery points, those are actually going to incur cost for you. So as you have more and more snapshots on your replica side, that's going to impact your storage space. Not only storage space, it's also going to impact your storage IOPS because we need to take care of merging these snapshots in a periodic fashion and take care of keeping them up to date. Last but not least is memory and CPU impact. So the memory impact is about 50 megabytes per replicating VHT, and the CPU impact is actually quite minimal. Someone taking a picture there. Okay, so enough of all the boring stuff. Okay, so now let's switch to something more interesting. Okay, so while I was doing the test failover demos and planned failover demos, I was kind of watching some people. I was just kind of remote sensing that, hey, this guy is actually replicating between 2 laptops or replicating between 2 servers that are, sitting next to each other. It can't be real, right? So I'm just going to dispel all that myth and turn it over to Mike, who's actually going to show you something cool.
Hi.
Mike?
Thanks, Vijay. My name is Mike Vandermervy. I've been working on Replica for about a year and a half, 2 years now. Let me ask you a quick question. How many of you would have deployed Windows Server 2012 at beta in your production environments? One person.
One brave soul.
So for the last 2 years, we've actually been working and having Replica deployed at customer production environments to see what the impact was, to see if the product was usable. Did we run into issues? Absolutely. But the thing was that we actually had customers testing this and using it in the production environments. I guess another couple of questions I should ask is, how many of you are in hosters or service providers? About 30 people. Enterprises? Large businesses? 30, 40 people. Small business? Small handful. And how many are partners for small businesses? And another small handful. So over the last year, one of the things that we knew we wanted to focus on were customers testing in hoster data center to data center environments, enterprise data center to data center, and small business to hoster replica environments as well. One thing that we didn't count on was having customers in the small and medium business partner space actually want to use this as a service to provide disaster recovery services to their customers. and also to kind of give an example of both small business backup as well as backup to a hoster, what I've done here is worked with a couple of companies, one based out of New York City called Work IT Safe, and one based out of Belgium called HostBasket, to set up a demo for you that I will quickly run through so we have some more time for questions at the end here. And basically be able to show you that Replica is working in real environments with real people right now. So these customers that we've been working with actually have customers replicating to them currently. Work IT Safe is actually working with 2 customers in their production environments. So what I've done here is I have a basic test machine set up, nothing major because I don't have the time to do a full replication. But basically what I'll do is I'm going to enable replication and start the VM. You can see here that it goes through. And basically, I mean, you've seen everything that VJ did. You've seen the PowerShell. You've seen the GUI. So this is definitely the easiest way to do it. But it shows you also that companies in the small business space and companies that don't have a lot of experience with PowerShell or with the server platform are able to do this very quickly and very easily. It's 3 lines of codes to enable replication from here to Work IT Safe based out of New York City. It should come back, and there we go. It's starting the initial replication. Good. So you'll see that everything is normal. Replication health is normal. And right now we have a machine over in New York City. Let me close this for you and just show you. Right here. That is currently off. It's a replica machine. But what you've done is I've been able to use my laptop as an example. But just imagine that's a server rack with a bunch of servers in it. And I am replicating, and I have a disaster recovery plan now for the machines that are running on this specific machine. Now, there's a couple of gotchas here. Obviously, you can't just throw a machine on your network and expect it to work. There's a couple things that you'll need to do. The first one is you need to have a publicly facing IP address on the hoster side or on the small and medium business partner side in order to be able to receive replications from your customers. The other thing is that if you are behind a NAT, which I am because I'm just on the same network that everyone else here is using, you need a VPN connection in order to be able to do replication from the hoster or from the small and medium business partner back here. And so what I've done here is to kind of show you the entire disaster recovery piece. I'm going to fail over. So in a moment, it's asking me if I want to perform this action. Yes. And so it's performing the plan failover. And now you will see that although everything works properly, here in VJ's example, you would have had the option to plan a failover. So right now I can cancel plan failover, but I'm not going to do that. I'm going to say that right now, because we're packing up here and I want my machines to continue running, TechEd's at an end. I want to be able to have those machines accessible to my customers, to my clients who are using those servers. I'm going to switch over to the site in New York City. And let me just make sure I get the variables in there. So this is going to complete the failover for me. And I want to complete that action. So let me just go back to the GUI to show you this. So right now, application. Yeah. So right now the machine is completely on this. On the New York side of the Atlantic. It's accessible there. If I turn it on, it will be accessible there for customers to use, for the people in my office to continue to use. Now, say I want that to be a more permanent arrangement. And once I get over to, once I get back to the States, I'm going to enable reverse replication because I still want a disaster recovery plan in place. And my laptop will be with me in Seattle. So whatever things have happened in the 2 days that I'll be offline, I'll enable reverse replication to go back to the laptop now. And basically what we have now is you have a server that's running in New York City that was initially running on my laptop here and replicating from my laptop to the server in New York City, is now running completely in New York City and replicating back to my laptop. Yeah. So if that's something that's interesting to you, let me know. because it's something that we've been working on for quite some time. So a number of gotchas, like I said, VPN connectivity, public IP address for your hoster. One of the things that we actually discovered during the TAP was that hosters, actually enterprises, anyone, doesn't like having to assign a single IP address for each connection that they have into their company. So one of the major changes we made is to be able to use a single public IP address for all replication traffic into the site. Other than that, that's the end of that demo. So thank you very much.
So before I close, I know you guys have been hanging out for too long with me. This is Friday afternoon. So before you leave the presentation, I just want to make sure that you have all the related content associated with the talk. This is the hands-on lab. If you didn't check it out, you can also see the blog post that we are actually actively putting our stuff in there. And make sure that you check out the blog continuously so that when we post the capacity planning tool, you actually have access to that. We also have documentation. Documentation is going to be updated pretty late. I mean, it's right now in beta documentation. We'll actually be updating it pretty soon. So again, thank you for coming. And make sure that you do your evals. And make sure you be gentle to me. Thank you.